essential to running a plant efficiently and safely. There is an array of flow technologies available to make these measurements, including the electromagnetic flow meter, oftentimes referred to as a mag meter. Mag meters are selected because they are obstructionless, cost-effective for aggressive chemicals and slurries, and provide a highly accurate volumetric flow measurement. Mag meters are comprised of a transmitter and sensor that together measure the flow. The mag meter sensor is placed in line and measures an induced voltage generated by the fluid as it flows through the pipe. The transmitter takes the measured voltage generated by the sensor, converts the voltage into a flow measurement, and transmits that flow measurement to a control system. To make the flow measurement, the mag meter utilizes a set of coils and a pair of electrodes. The mag meter's coils are driven by the transmitter with an applied current. Once powered, a magnetic field is formed between both coils. Once the pipe is full and the fluid begins to flow, the force of the magnetic field causes the negatively and positively charged particles of the fluid to separate as they pass through the magnetic field. This separation causes an induced voltage to be formed between the electrodes and the sensor. The conductivity or charge of the fluid in the pipe must be at a certain level for the transmitter to measure the induced voltage at the electrodes. This flow principle is known as Faraday's law, mathematically defined by the equation E equals K B D V, where the induced voltage E is directly proportional to the velocity V of the fluid moving through the magnetic field B. The induced voltage is carried to the transmitter through the electrode circuit. The transmitter then converts this voltage into a quantifiable flow velocity. With the known velocity along with the area of the pipe, the volumetric flow rate of the fluid is calculated. To prevent electrical shorts of the sensing component circuitry, the pipe of the flow meter is lined with a special material known as a liner. This liner, along with a selection of the proper electrode materials, is important to protect the sensor against abrasive and corrosive chemicals and solids. One historical limitation of mag meters is the impact of process noise. Process noise occurs when particulates impacting the electrode interfere with the induced voltage measurement, generating a false reading. Rosemount has become a true expert regarding material compatibility for appropriate liner and electrode selection, and has advanced digital signal processing software to provide maximum measurement reliability for even the most challenging applications.